Okay, so now I'm going to show you how to solve a system, remember, which is just two equations. A system that's by elimination. I know it's a dead giveaway for elimination because it's just everything's all perfectly lined up. Straight, 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 right underneath each other. So the reason this is called elimination, because the goal here is to eliminate, which means to get rid of, destroy, right? But the only way that we can destroy things is if they make a zero. And the only way to make zeros are from two numbers that are the exact same, but different. I'm trying to use prime numbers here, -11, right? So all of these things always make zero, right? So we need to make some zeros here. So I don't see same but opposites here or here or here, which is sort of frustrating. So it's like, okay, that's annoying. In an ideal world, I wish this was a -3 so that these two could just eliminate each other. But that's not what I'm given, so I can't just put a -3 there for no reason. In an ideal world, like this would be -6, and then these would cancel each other out. So really, it's just a matter of understanding that like something has to go, and you get the choice of which. So for me, I think the easiest thing that I see is, okay, like this is 3, but in an ideal world, I think I can make this a -3 pretty easily. So I think I'm going to leave that bottom equation the same. And there's lots of things that you can do to get the exact same answer. Maybe I'll show you that on the next example. But I'm not given the ideal situation, so what I have to do is I have to force that to happen. And so in my brain, I'm trying to get rid of x's. To get rid of x's, I need the same number here and here, but one of them has to be negative. Since this is already a +3, I want to turn this into a -3. The number that's actually hanging out right here right now is 1. So what I need to do is figure out how to turn this one here into the ideal answer here, which is -3x. And so the thing that I have to multiply this 1 by is -3. And so now if I multiply 1x times -3, I get -3x, which now we have the world's most ideal situation. And now what I'm going to do is I'm going to multiply everything in this statement. You can't change just this without changing the rest of these as well. So -3 times x is -3x. -3 times 2 is -6 with a y. -3 times 6 is -18. And now we're going to work up and down. So -3x together makes no x's. I don't have to write that. -6 and 6y together makes no y's, equals -18 and 8 makes -10. I can't just leave a blank spot. There's nothing over there. And if there's nothing over there, now we need to put something there. So our universal number for nothing is 0, right? And again, this is one of these weird statements where you have to assess like, okay, what does this mean, right? Well, 0 doesn't equal -10. So this tells me that there's no solution. It means if I graph these two equations on Desmos, the lines will not intersect. And I can prove that to you in lots of different ways. That was from the last problem. So we've got x plus 2y equals something. And, 6. You know what, I'll just duplicate it. Change the color so you guys can see. That other one was 3x plus 6y equals 8. Okay, so the green one was our top equation, the bottom one is our blue equation, and notice the lines are parallel. I can zoom out as much as I want. Not too much though, because now it makes it look like the same line, but that's just because I'm so far zoomed away from it. But yes, we know the lines are parallel, and if the lines are parallel, they'll never cross, and if they don't cross, then there's not a dot that's on both lines, and so there's no solution, etc., etc. All right, so what this just means is that I asked you to solve nonsense. That's just like saying, hey, I want you to walk forwards and backwards at the same time. Just because somebody tells you to do something doesn't mean you actually can do it. Just because they give you two equations doesn't mean they actually have anything in common. All right, so this statement here is a no solution, which means it came from parallel lines. Let's do one more just so you guys can see it. Again, it's set up for elimination. What does this mean? It means nothing is the same with both of these numbers, so I have to choose one of the letters to go away. So I'm actually going to do this problem twice so you can see this giving you the exact same answer. So first I'm going to get rid of the x's, and then I'm going to get rid of the y's. All right, so how do I get rid of the x's? I can't turn 5 into a 2 or a 2 into a 5, at least not with nice whole numbers. So I think 5 and 2 can both grow into the number 10. So what I'm going to do is I'm going to multiply this top equation by 2. If I pick something that's terrible, I'll just adjust it with this arrow. But right now, all I'm going to do is I'm going to multiply everything by 2. And if I multiply the 5 by 2, I get 10 with a minus sign. 4 times 2 is 8 with a y. 2 times 2 is 4. So I'm essentially doing like a giant distributive property. Now remember, my goal in the end was to get rid of x's. So in an ideal world, if I have negative 10 here, I want to see 10x here, but I don't. I see a 2x. So I'm trying to think of like, how do I turn a 2 into a 10? And so I think I could just multiply that by 5. And if I do that, 2 times 5 with a x is 10x. 5 times negative 3 is negative 15 with a y. Don't forget, 5 times 5 is 25. Big mistake is that kids forget to do one of those multiplications. Big distributive property. This to this, this to this, and this to this. And then now that I have same but opposites, these will go away because they produce a 0. And then I just compress these. 8 minus 15 is negative 7y. 4 and 25 is 29. I'm going to divide both sides by negative 7. I thought I planned this so it wouldn't be so terrible, but that's fine. We'll just do a decimal because sometimes that happens. 29 divided by negative 7. Ugh, a terrible decimal. Why did I do that to you guys? Hold on. Let me see if I can adjust this real quick. I thought I checked the answers really before I made these so they wouldn't be too terrible. Hold, please. Can you hear me typing? Oh, yeah, that is correct. That's a terrible number. Okay. Hold on. I'm going to change the problem just to be slightly nicer. Hold on. 2x minus 3y. Oh, dang it. You know what it was supposed to be? It was supposed to be a minus sign there. Pretend like there was a minus sign here the whole time. I was like, I thought I designed this problem nicer. Okay, that doesn't change anything. 5 times 2 is 10x. 5 times negative 3 is negative 15. 5 by negative 5 should be a negative 25. That should be negative 25. 4 with a negative 25 is negative 21. Divide both sides by negative 7 and you get y equals 3. Okay, so that was just a design flaw because I wanted the problems to turn out to nice. Okay, so then once I have that first letter, I'm going to choose one of the equations. I don't know, the top one looks nicer to me now. I don't really know. So I'm going to take the exact top equation. I spent all this time figuring out that y was 3, so now I'm going to use that idea. I'm going to just replace the y with 3. 4 times 3 is 12. And then it turns into a problem that we're sort of familiar with. 2 minus 12 is negative 10. Divide both sides by negative 5. And x equals 2. A negative divided by negative is that positive 2. So there are 2 solutions. Okay? I'm going to do this problem one more time, but I'm going to do this now with eliminating the other variable, just so you guys can see that it really doesn't make a difference. Make sure I put that minus sign in there. Stupid minus sign. Okay, so same equation, but now I'm like, ooh, I really am a person that likes to cancel out y's, and that's totally fine. It's whatever you gravitate towards. So what I see right away is that 4 and 3, 3 doesn't turn into a 4 nicely, 4 doesn't turn into a 3 nicely. Like 3 times a number has to give me 4, and I don't think multiples of 3 go into 4, and I don't think multiples of 4 turn into 3. So you're not going to get any whole numbers there. So if your plan is to get rid of the y's, then you have to think about like, okay, 4, if you count by 4s, 4, 8, 12, 16. And if you count by threes, I'm going to ignore the minus sign for a second. 3, 6, 9, 12, 15, blah, blah, blah. Then what do these have in common? And the first number that I see is 12, right? So hopefully you understood that before me listing those numbers, that 4 and 3 can both be turned into 12. So I'm just going to multiply this by 3. And then I think I'm going to get the number that I want. So negative 15x, because again, don't forget, multiplying this, 12y, multiply this, 3 times 2 is 6. Now again, stop and check. Your goal is to get rid of the y. You have a 12 here, so in an ideal world, you want to see negative 12. You have a negative 3 here, so to turn negative 3 into a 12, I only need to multiply by 4, okay? So hopefully I did everything right. If I didn't, I'm just going to go back and fix it. 4 times 2 is 8x. 4 times negative 3 is negative 12y. Negative 5 times 4 is negative 20. The 12s produced together make a 0, so I don't need to write those. Negative 15 with 8 is negative 7x. 6 minus 20 is negative 14. Divide both sides by negative 7, and x equals 2. So if you notice, the answer for x equals 2 is the same for both of them. It's just going to get you in a different order. So if you eliminate x's first, you're going to solve for y first, then get x. If you eliminate the y's, you're going to solve for x first and then get y. And you'll get the exact same answer, but I promise you that if you do what I just did here, you'll get y equals 3 as your second answer. And hopefully that helps. Good luck studying. Let me know if you need anything.